the big other thing I want us to do to review before we start heading towards some calculus stuff is to talk about functions. And I know especially the ones of you that took dual enrollment, you probably got tired of hearing about functions. Do you remember having to talk about them a lot?
Yeah.
Vaguely.
I remember not loving them.
Yeah. So, our main goal with functions in calculus, the big thing for us to talk about is that if you have two functions or more, you can put them together to make new functions in lots of different ways. So, we've got some easy little rules here. Refresh your memory on. So, if we've got two functions, we're going to call them f and g. So, what do I mean when I say a function? What is a function? That's a hard math question, but you don't have to give me a complete theoretical definition or anything. Just what do you think of when you think of a function in math class? Yeah, okay, so yeah, we use them like that. We'll plug in some value for x and see what number we get out. Anything else come to mind?
It's when a variable is used to mean an expression instead of just a number.
Alright. Yeah. So both of those are on the right track. The issue I have though is we're leaving out one important property functions have. And you can think about the graph. Just think about graphs of functions. Maybe if you think back and it gave you a graph and it said determine if this is a function or not. What did you have to check? Do you remember?
Only one, like x value for every y value.
Oh, yeah, so I wish you're getting fancy. What? Above expectations, I'm just thinking like, what kind of test do you do?
Parallel line.
Vertical line test. Vertical line test.
Yeah,
So,
that's not parallel line.
yeah. So vertical line test. So instead of just telling you, I'm making you try to recall it because it'll help you remember it next time. Vertical line test. So what's the vertical line test say? If we've got some graph.
You put a vertical line on it, it can't cross the graph.
Yeah.
More than one place per time.
That's right. So no matter where we put a vertical line on our graph, another way of saying that is if there's nowhere we can put a vertical line that crosses our graph more than once, then that graph represents a function. If we have something more like this, we got like a sideways parabola or something, then that one's not going to be a function because there are lots of places we can draw in a vertical line where it's going to cross more than once, so that would not be a function. And so that's kind of the big takeaway we start out with when we're talking about functions. So this idea we're going to look at, and you probably seen it before, you just might not remember details. Okay, but if we start out with two functions, we can put them together and make new functions. So that means that if the graph for f and g pass the vertical line test, then we've got ways we can stick those things together and make new functions that still pass the vertical line test. So we're still maintaining that property. So we've got the four basic operations we want to be able to do. One thing we can do is we can take our two functions and add them together and get a new function. So the rule almost looks too simple to be bothering with writing it down when you see the rule. It says if we want to add two functions together to get a new function, how do we do that? We just figure out our value at f of x, figure out our value at g of x. These are going to be two numbers, and we add those two numbers together to figure out the value of our new functions. That's almost so simple looking that why bother writing it down? If we want to put two functions together with addition, we just add the two things together. Ring a bell? What about if we want to make a new function using subtraction? Same thing, yeah. It's just really easy, and we just take the value of the first function and subtract the value of the second function. We can do the same thing with multiplication. If we want a new function that we're calling f times g of x, just take f of x, multiply that by g of x. One more. What are we missing? Division. Divided by g of x, just f of x divided by g of x. But division always makes things a little more complicated. What can happen when we divide out? We can add any numbers we want to, subtract any numbers we want to, multiply any numbers we want to, but can't divide by 0, so we have a little extra information we have to put in here. We gotta make sure that g of x is not 0. If g of x happens to equal 0, then we can't get a new function that way. It'll be undefined. G of x equals 0. Okay. Question on any of that? Good. Yes, you may. Nothing too complicated there. It's really nice, is what it is. Like when you're doing a bunch of other math and you say, well, what if I want to add these two things together, and you have this really ugly thing over here that tells you how to add them, then it makes you appreciate these. But when, it just looks really easy, and you haven't seen anything that could turn out worse, then you don't appreciate it. So, one other big idea with functions. And that's this idea of domain and range.
That's so
So just in plain language, you don't have to be real mathy here. What's the domain of a function? Well, the range you could say would be height. Thinking about the graph. Yeah, that's right. Yeah, so the domain is just the x values for the set of inputs function.
Range is like opposite.
Yep. So range is a set of y values. Or the set of outputs that we can get out of the function. So we kind of dealt with that a little bit right here, and like we said, this one's not gonna work, and if our input makes g of x 0, right, we can't have that, so whatever value would make g of x be 0 here would not be in the domain of the new function. So let's put some, my mask is not playing nice today, it keeps trying to get in my eyes. So let's think about putting some of these together. They're not difficult. For the most part, the ones we're going to deal with. Two functions. F of x is x squared plus 2, g of x is square root of x. It's behind f plus g of x. So how do we do that? Our rule says f of x plus g of x f of x is x squared plus 2 plus g of x is square root of x.
The x's are gonna cancel out.
Not on this one,
Really?
because it's plus. And like
Like
if you
the
had
x
the
squared.
square root squared, it would cancel. Right, that's what you're probably thinking about. But here since it's plus and they're not exactly the same exponents, there's nothing else we can do there. So we're finished. That's our new function. Yeah, sometimes you can simplify, but on that one, nothing really simplified. What about f divided by g? Yeah, just x squared plus 2. G is square root of x. We're okay there, except what, when we divide, we can't let the bottom be 0, right? So this is good everywhere as long as square root of x is not equal to 0. When would the square root of x equal 0 if x was, yeah, so, or we can say, kind of mark that out, so where x is not equal to 0. Do one more, not any harder, but if you try to simplify, it can make it a little messier. What about f times g of x? that's x squared plus 2 times square root of x. And most of the time, you're okay just leaving it just like that. But just as a review, how could we multiply that out if we wanted to? For some reason, we're just gluttons for punishment. We just really want to multiply that out. How would we do that?
Yes, what was the whole thing?
Close. So, square root of x, we could rewrite that. Instead of writing square root, we could change it to some kind of exponent. We could change it to x to the 1/2 power. So that's x squared plus 2 times x to the 1/2 power. And then we could do distributive property. And it looks weird because our single term's on the right. We still distribute that. And what's our rule when we're multiplying? What do we do with our exponents? We add them. Yeah, add them. So now we're off in the fractions. We got 1/2 plus 2. What would we get? X to the 5. We could do that if we wanted to. I got a common denominator now. 2 is 4/2. We got 4/2 plus 1/2 is 5/2. On that particular problem, it's fine. We'll leave it here. A little bit down the road, though, we'll want to be able to deal with these fractional exponents. Let's see. Actually got some problems out of the book. We're on page 49. Just those for in there. 31, 32, 33, 34, 35, 37. You may need a book. I got theirs today. If you ever forget yours, remember I've got 4 or 5 over here in the cabinet.